You might have stumbled upon the widely adopted EDF data format when looking at time series, especially in the medical field. These files are an ubiquitous data format that has been in various research projects like polysomnography studies since the early 2000s. You might be asking yourself, what exactly is this format? Why is there an EDF and an EDF Plus? And how to pragmatically use these formats for experiments? In today's short video, we'll take a deeper look at the EDF data format and use a real sleep study dataset to programmatically open it using Python. We'll first go through a quick history of the format, which gives good insight into its underlying structure. We'll then check out a high-level overview of these two formats. We'll then open up an EDF file and check out what the raw information look like. And finally, we'll jump into a notebook to check out to open these type of format programmatically to start analyzing them. Let's start with how this format came to be. Way back in 1987, Bob Kemp and other European medical engineers like Annelies Rosenfalk got together at a conference in Copenhagen. At that conference, a few of these engineers agreed to collaborate on various projects under the Professor Annelies' supervisions. The project was named Methodology for the Analysis of the Sleep-Wakefulness Continuum. The engineer wanted to apply their sleep analysis algorithm to each other data and compare the analysis results. The issue was that as the engineers collaborated, all their data were in different formats from different labs. These recordings had to be sent back and forth and structured on either end to fit whatever analysis they were doing. So in 1990, the researcher agreed upon a simple format to ease all of their exchanges of polygraphic data. This led to a paper written in 1992 that detailed that format called a simple format for exchange of digitized polygraphic recording. This standard, called the European Data Format (EDF), became popular and was a de facto standard for electroencephalographic and polysomnographic data. By the way, if you're interested, I got a paper link in the description. It's a short read. The standard was so popular that other medical researchers tried to use it. However, their main concern was that the EDF format could only store contiguous recording in one file, meaning that the file was from start to finish one session. This was especially problematic for researchers and dealing with evoked potential data or myography data. So in 2003, Bob Kemp and other researcher Jesus Olivan got together to revamp the format. This led to EDF Plus, which had a much broader appeal where all physiological data can be stored in it. Let's take a look at these two formats. At a glance, the EDF format is structured in two sections, a header and a data recording session. A bit like an image, you have the header and then you have, after that, the byte containing the information. The format is made to have one file per recording for one patient. The header contains meta information about the patient and technical characteristic of the signal. The signal are stored right after the header, and in the EDF case, the data must be from a contiguous session. At the high-level overview, the different fields look like this. You have here the local patient identification, the local recording identification, start time, number of bytes in header record. Here you have the physical maximum, minimum of the different sensors that you have. Right afterward, you get the data record section for each signal, one after the other. The EDF Plus is mostly the same as EDF, but it can now store non-contiguous information, so as to include all physiological data possible. EDF Plus also added into the data record section a way to store annotation and event directly into the same file. Make it very versatile. It's also super handy for machine learning studies using neurophysiological data, since you can have the label really close to the time series. Alright, let's take a look at the raw example file to see what it looks like in practice. So here it is, there's an EDF example file. At the top here we have some information about various dates. Here the start date of the recording. Then we have a bunch of information about the signal that we are recording. Here it's mostly EEG stuff, and then here we have some annotations. You see like here the units of the whole thing. You see here the high point, the low point. The format is a bit weird because there's a bunch of tabs and stuff, but what you need to understand is that this part from top to bottom here is the header, and right after that, this garbled mess, which are like literal bytes of the information, is the data. So this is like each of the data points that we are recording for the many signals that we have, and then it goes on and on and on and on and on. And you won't be able to open up a file and kind of guess what the heck is happening. So to do that, you actually need to programmatically open it and let some sort of library engine put this into something that you can work with. A bit like opening a PNG or a JPEG file. Okay, you won't understand the image, you just have to open it properly with something that understands the format. Now that we know what we are dealing with, let's load an EDF Plus file using Python. There are many libraries you can use. My particular preference is to use MNE-Python, which has some very neat APIs. Let's check it out. So here we are into the code. So to check out the EDF format and how to open it. So first off, what you need to do is actually install MNE. So here I'm doing pip install MNE-Python, and then it will go and actually do it. Okay, so now it's installed. And here I can import whatever I need. You see here I need MNE, and then I need to fetch some data from PhysioNet. So it's just a sleep study. Okay, and here's the code I'm using to actually load the EDF file programmatically so I can use it. You see I'm using fetch data to actually just get the data that I need here from this sleep PhysioNet. So we will download it. And after that, this is the actual thing that is important. So in mne.input-output, there's something called read raw EDF. So I'm downloading an EDF file, right? I'm storing it here in participant 0 file because it's ID 0. And then I put this raw EDF into this thing over here. And after that, I'm reading this thing to get the signal, get the header information and all. And here I'm doing read annotation to read on the second file that we have, because there's 2 files here. I can read the annotation file. So you see here I run this part, right? So I'm gonna download it. See, I'm downloading data from blah 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 here. I'm downloading this one, PSG EDF, and then there's another one I'm gonna download right after that. We're gonna see where it is. So you're gonna see there's 2 files in there. Okay, so the 2 data things are in root MNE. Let's take a look at it. So it's over here. So we downloaded the sleep data. So we have EDF here, and then we have a hypnograph. Yeah, that's EDF. So it's the same file, that is the same data that is in 2 different files. With the EDF Plus, like we said, you can do that and mix and match some stuff. So here the annotation are there, and then the actual recording is over here. In our case, what we're doing is we're getting the raw EDF, right? So this is a signal, and then we're getting the annotation, and then I'm using the raw EDF and I'm putting the annotation that I just got here with set annotation in this data structure. And then after that I can plot it. And if you can see the plot, and as you can see here, we have the different plots. So we have a bunch of EEG, we have a bunch of temperature stuff. We have our event marker over here, right, for the different stage that we are at in the sleep study. So it looks like this. So you can get them pretty easily. So we read the bytes here, we'll put them together. If you were to kind of just look at this data structure, raw EDF, you have all of this information. It was measured in 1989. There's a bunch of channel here. So 2 EEG, 1 EOG, 1 respiration monitoring channel, 1 EMG, and 1 temperature, and 1 stimulus channel. And sampling frequency and all the stuff here are stored within this. So you have everything you need to actually do the analysis properly. And then after that, like, you can either use this directly, and with MNE, there's many ways you can analyze the signal source. Or if you want to do something more custom and you don't want to be restrained, you can do raw EDF dot do data frame, and you're gonna get literally a data frame. So it's literally gonna be a time series. So you have your time step here until the end, and then you have all of your different signal here, including the event marker over there. That's it. That's what EDFs are. I hope this was useful. Don't forget to like the video if it was the case, and leave a comment if you have any question. I'm here to help. Have a great week, everyone, and see you in the next video.